Hey everyone. So in this video, I like to talk about variables, tables, and graphs. So in mathematics, we'll often be interested in analyzing quantities that vary, and we'll usually call these quantities variables. And so any quantity that changes over time or in different situations, we can think of as variables. And so maybe let me list a few different examples. Maybe something like a child's height can be thought of as a variable. Right, because this changes over time or as the child ages. Maybe another example might be the shipping cost of a package. Right, this might depend on the weight of the package. So we can think of the shipping costs being a variable because it'll vary depending on how much the package weighs. Maybe just to keep listing more examples, I'll include one more. Let's say the number of people at a park. Right, this might vary over time, maybe just the time of day, or with the temperature of the day. And so all of these are examples of variables. And actually, I should add that time, we can also think of a variable, or the weight of a package. You know, these quantities, they vary as well. This might be a variable, or maybe the temperature. So these things that these variables that we discussed a moment ago, the things that these depend on, these are also examples of variables as well. So in this next example, I'd like to talk about life expectancy. So life expectancy is the average age for which a person will live to. And this might depend on when that particular person was born. And so here in this sense, life expectancy is a variable. And so life expectancy, this depends on the year in which that particular person was born. In other words, life expectancy varies from year to year. We can think of it as a variable. And actually, in a similar sense, the year in which a person is born, this varies as well from person to person. I can think of both of these quantities as variables. And so here on the right side of this page, we have a table relating these two different kinds of quantities. And how do you interpret this table? Well, you sort of read these two quantities beside each other as related to one another. So for example here, the fact that I have 1920 beside 58 is telling me that 1920, it's representing a year in which a person was born. And here that's saying that their life expectancy for a person born that year is on average 58 years. So here, maybe I'll write that down. This is just saying that someone born in the year 1920 is expected to live 58 years on average, based on this table. That's how we read this table. And so maybe let's get a little bit more practice reading this table. Here I have the question, when was the life expectancy 68 years old? So if we look back at this table, and I encourage you to pause for a moment and think about how you would read this table. But here we're saying that we know, we're trying to make sense of when the life expectancy was 68 years old. Well, that's here on this table. And so what year would a person have to be born? Well, that would be in 1950. Right? So if a person was born in 1950, based on this table, they're expected to live 68 years total on average. And this next question I have, just to get more practice interpreting this table, is between what two decades was there the largest increase in life expectancy? So let's go back up to this table, and I'll give you a moment to look at this yourself. So where would you say the largest increase in life expectancy happened between what two decades? So maybe we can go through this from decade to decade. I can see here that this increase in life expectancy over this decade was just 2 years. But if we go to this next interval, from 1910 to 1920, we see that this increase was 7 years. Right, so maybe there was a lot of improvement in medicine in that decade. It's hard to say just from this table, but let's keep going and let's see if there's any 10-year difference that really increased life expectancy more than 7 years. Well, the following pair here, that's only a gap of 1. This is a gap of 4, 5, 2, 1, 3, 1. So really, there's no other larger increase between two consecutive decades than between 1910 and 1920. So this is these are the 2 decades in which there's the largest increase in life expectancy. So maybe let's write out these answers. So I guess we didn't write them down earlier. So here, when was the life expectancy 68 years old? That was in 1950. So here in 1950. And then between what 2 decades was there the largest increase in life expectancy? Well, this was between 1910 and 1920. So another way we display information about two variables that are related to one another is through something called a graph. And so let's imagine a situation where a plane takes off and we're recording the altitude of that plane at different times. So I have a table here where the left column describes the time after that plane is taken off in terms of minutes. And then in my right column is describing the altitude of the plane, or the height of the plane in the air, in terms of thousands of feet. And so here, when I look at this 8 that's in this right column, that's not saying that the plane is 8 feet in the air. This is saying that the plane is 8,000 feet in the air. In particular, it's 8,000 feet in the air 10 minutes into the flight. Okay, so how do we describe this information graphically? Well, here I've got this grid on the right, and I have 2 main lines here, one that goes from left to right that I'm going to call my horizontal axis. And this is going to correspond to our first variable. It's going to sort of help us measure our time. And then I have a vertical axis, this line that goes up and down. It's going to be there to help us measure our second variable, in this case, the altitude of the plane. And so how do we take this information from the table and put it into a graph? Well, what we do is we plot points. So every single location on this grid on the right, this corresponds to both a time and an altitude. Any one spot on this grid corresponds to a time and an altitude together. So I mean, this isn't the case. This isn't a point on the table, or a pair of numbers on the table. But maybe just to give you an example, if I said, let's say I plotted a point here, this would be like saying that the plane, after 100 minutes, right here, this is time is described in terms of minutes. When I look to my time axis, this point is located relative to the 100th position. And then when I look to my altitude axis, my vertical axis, this point is located at that 20 mark. Well, this is then saying that together, that plane is 20,000 feet in the air after 100 minutes. And so maybe let's use our example that we had earlier. So here, we highlighted the fact that 10 minutes into this flight, the plane will be 8,000 feet in the air. So what this is saying is that Well, here, if each of these tick marks is 10 apart, then that makes this line here, or this spot on this horizontal axis, 10. And so what we're saying is that here is our point, because when I look down to my vertical axis, my horizontal axis for time, this point corresponds to 10 minutes. But then also when I look to my vertical axis for altitude, this point corresponds to, this is roughly at a location of 8 on this axis, and that's our altitude axis. So here, that's saying that we have, the plane is at 8,000 feet in the air. And so let's do this for all of our points. So here, this first point, this 0 for time and 0 for altitude. Well, 0 for time would be here, and 0 for altitude would be here. So that's the location of this point. At 2020, well, that's saying that's this point here. Right, maybe let's make sense of y's, right? So if I look down to my time axis, my point corresponds to a time of 20 minutes, and if I look left to my altitude axis, my point corresponds to an altitude of 20, which means 20,000 feet in the air. Okay, so let's keep going. So at 30 minutes into our flight, we're at an altitude of 21, so it's not all that much higher than where we were before. But if we look down to our time axis, we're still at that 30 mark. If we look at 40 and 23, what we're saying is that 40 minutes into the flight, we're at a height or an altitude of 23, so that would be, that'd be about here. Okay, so what else? We've got 50 and 28, so that's saying that here we would have this point, because if I looked down to my time axis, I would see a time of 50. If I look left to my altitude axis, I would see an altitude of, well, 28 thousands of feet. So maybe I'll erase this pink for now so it's not too cluttered in this picture. But this is how we relate the information on the table to this grid, right? So every point on our grid corresponds to both a time and an altitude. One thing I want to deter you from thinking, so maybe let's look at this next one. So we already did 50. So here, I've got 60 and 29. So one thing that you would not do to plot this information on the grid on the right is I would not just plot one point at 60 for time and one point at 29 on our altitude axis, right? So this is not two different points, this is one point, right? So 60 and 29 together would correspond to this point here-ish, right? Because when I look down to my time axis, I would see 60 minutes, and when I look left to my altitude axis, I would see an altitude of 29,000 feet. Okay, so hopefully that clarifies things. I'll keep plotting some more, but I'll go through this next bit a little bit quicker. So at 70 minutes into the flight, we're at an altitude of 30,000 feet. 80 minutes into the flight, we're at 25,000 feet. 90 minutes into the flight, we're at 13,000 feet, so 13 would be about here. And then 100, we're 5,000 feet in the air, and then at 110 minutes into the flight, we're at 0 feet in the air. So these are the pieces of information we have on our table, but in a graphical format. And oftentimes, you'll see these points sort of connected with a curve. There'll be some sort of smooth curve that goes through all the different points. And this is usually what we call our graph. So here, this helps us just to make some approximations or estimations about the general trajectory of the flight of the plane and what happens in between our data points. So here, this curve that I just sketched out, that's what we call the graph. And so all of these little points on this curve that I sketched out, everything in between, these are examples of both times and altitudes together, and they're just there to help us make sense of this plane flight, the heights and the times. So now let's use this graph to answer a few different questions about the plane and its altitude. So the first question I'd like to ask is, well, let's estimate the altitude of the plane 85 minutes into the flight based on our graph. So here, our time axis, this is describing, how long into the flight we are. And so what we're doing is we're going to look along our curve and see where we have a point that corresponds to a time of 85 minutes. And so, 85 minutes along this time axis, well here, here's 90 minutes, 85 is right between. And so what point corresponds to 85 minutes on our graph? Well, so here, maybe this point, on our graph corresponds to 85 minutes, because when I take this point on our graph and I look down to the time axis, it'd be the only point on this curve that lands at 85 minutes. Right, so here, that's our corresponding point. What's the altitude? I think it would be safe to say that the altitude, it's just below 20. This line here is meant to represent 15, right? It's right in between 10 and 20. And so this is closer to 20 than it is to 15. I think it'd be safe to say that the altitude is 18. That's a good estimation. So here, the altitude of the plane, 85 minutes into the flight, I think it's approximately 18,000 feet. So the next question says, when did the plane have an altitude of 10,000 feet? So if we go back to our graph, maybe I'll erase some of this purple that I've drawn in here. So we're looking for when the plane had an altitude of 10,000 feet. What points on our curve correspond to an altitude of 10,000 feet? Well, 10,000 feet, that's going to correspond to our altitude axis. And 10,000 feet, that's measured here vertically. Right, so what points correspond to 10,000 feet along our vertical axis? Well, this point here on our curve and this point here on our curve, these are 2 points that both have an altitude value of 10. And so what would those be in terms of time? In minutes, well, here this first point on the left, if we look down to the time axis, that's a little bit after 10. And then here, this second point, well, it's a little bit after 90. So it might be safe to say that maybe at 11 minutes and maybe at 90, I would say 93 minutes, we have the plane at 10,000 feet in the air. So at about 11 minutes and 90, what did I say? I think I said 93. 93 minutes. The plane is 10,000 feet in the air. Okay, so the next question I'd like to ask about our graph is that when is the plane descending? So if we go back up to our graph, we can kind of see that the higher the points are, the higher the altitude is, right? So for example, this point here is describing when our plane is at an altitude of 30,000 feet. This point here is describing when our plane is at an altitude of 20,000 feet. And we can see that the plane is going to be descending whenever this graph, whenever this curve is going downwards, right? So here on this part of the curve, we can see it's saying that as time goes on, I'm looking from left to right along this curve, the altitudes, the points are going down, so the altitude is going downward, the plane is descending. And so this is between where we're asking what times is the plane descending. Well, this is really from 70 minutes, right? So this is really saying at 70 minutes, we've got the plane is at 30,000 feet in the air. And it's descending all the way down to, well, this would be at 110 minutes. The plane is at 0 feet in the air. And between that time, the plane is constantly decreasing its elevations, going down, it's descending. So between 70 minutes and 110 minutes, the plane is descending. So let's do another example of using graphs and interpreting graphs. And before we really dig into this example, I'd just like to add in one little statement, is that sometimes we'll use letters as a shorthand for variables, just to be a little bit more concise and declutter things. So here, I have a graph that describes, one variable is the year, ranging from 1929 to 1941. And then another variable is the unemployment rate. So this is a percentage, and what we see here are values between 0 and 25. And so, instead of referring to the year or the unemployment rate, in those terms, we might use a letter to represent those ideas. So, I might say that U can represent the unemployment rate. And that T might represent year, and we might use that variable T because T is often used for anything in terms of time. And then when we say something like U is equal to 18, well, this will refer to the idea that the unemployment rate is 18%. That's kind of what we mean when we say U is equal to 18. Once we've defined U represents the unemployment rate, that's what it's symbolizing. If we don't say anything like this here, then saying U is equal to 18 doesn't really make any sense. We really have to define our letters and explicitly state what they mean if we want to use letters in place of variables. So that's just something to mention there. Okay, so anyways, let's get to interpreting this graph here. So here, So one question I want to ask about this graph is, what was the unemployment rate in 1930? So I'd encourage you to pause the video and see if you can kind of make sense of this answer to this question, or see if you have any idea. So here, hopefully this was clear. So here, this horizontal axis, we can see that every one of these tick marks here is another year. But I didn't have space to write them all out, so I only wrote out every other year. But here, this tick mark corresponds to the year 1930. And so the point that lies above it on our graph, right, this is the point corresponding to the year 1930. And here, that's about an unemployment rate of 8%, right? If I look at that point's relationship to the vertical axis, our unemployment rate axis, that looks like it's about 8%, maybe 9%. Maybe let's go with 8 for this example. So here this is 8%. And the next question says, when did the unemployment rate first reach 15%? So if we look back to our graph, Here's where unemployment rates are 15%, and if we look along our graph, well, there's multiple times where there's an unemployment rate of 15%. One time happens here, one time here, one time here, and one time here, but we're really only concerned with the first time, right? That was what the question asks, is when did the unemployment rate first reach 15%? And so here is the point corresponding to an unemployment rate of 15% the first time. And if we look at its relationship to the time axis, well, it's just a little bit before 1931. And so, here we can maybe say, it depends on how precise we're going to get, but I think maybe for now, just to avoid getting too careful with this problem, I'm just going to say approximately 1931. And approximately 1931 is when the unemployment rate first reached 15%. Okay, and then this last example, this last question that's asked, says, during which year did the unemployment rate show the greatest increase? And so if we look at our graph here, it's increasing when the graph is sort of trending upwards from left to right. Right here, the fact that this graph is going upwards in this part is telling us that, well, before it was a lower number, a lower percentage, and here it's at a higher percentage. The unemployment rate increased between those 2 years of 1929 to 1930. And then if we look at this part of the graph, we can kind of see that between these 2 points, the graph is sort of decreasing from left to right. We can kind of see that between 1935 and maybe 1937, we sort of went from a larger unemployment rate to a smaller unemployment rate. The graph is decreasing. The unemployment rate decreased between those years. So if we're trying to find the place or the year in which the unemployment rate increased the most, we're looking for when the graph sort of went up the most between two tick marks. And so really, where are some candidates for where the graph went up the most? I would say, somewhere here, somewhere along these parts of the graph. And so let's make sense of this a little bit. So, between these 2 years, between 1929 and 1930, it looks like we went up from maybe, let's say, an unemployment rate of 3% to an unemployment rate of 8%, we said earlier. So that was an increase of 5% in that single year. And then here it looks like we're at an unemployment rate of, I would say, 16%. So from the previous year to 1931, this would be an increase of an unemployment rate of 8%. And then this last year from 1931 to 1932, right, I would say that this would be about 23% unemployment rate. And so that would be an increase of 7% from the previous year. And so I would say here in this interval is when the biggest increase happened. So from 1930 to 1931. So during which year did the unemployment rate show the greatest increase? Well, this was in 1930 based on our graph.